special day because we have a whole bunch of short talks, lightning talks by a bunch of students doing a wide range of things. And I think, I wouldn't say there's a quiz involved here, but one of the cool things I'm going to be thinking about is the ways in which there are similarities across these very different talks, which we find often as we're thinking about sustainability problems and approaches to solving them, that even when the problems are different or the stakeholders are different or some of the science or other forms of knowledge are different, that there's some really common things to be on the lookout for. And that's one of the fun parts of being in the Mitchell Center, because a lot of the work we do involves different people, different partnerships, different disciplines, and so on. I've already talked to the presenters, who you can kind of see up here, and if you need a program to know who the players are, back in the back, just to the right of the snacks, is a sheet that you can see it all, and you could pick up snacks on the way, which is even better. Oh, by the way, I'm David Hart. I'm the director of the Mitchell Center. And just one small change for the speakers. I had warned you that at 5 minutes a sound was going to be made, and it was going to be my duck quacking on my phone, but we've made a last-minute substitution because my co-instructor, Tyler Quiring, has come to the rescue. And it's going to be, what do you call it?
Cuckoo clock.
Oh, cuckoo clock. So you'll recognize it when it happens. Oh, and I'm going to hold up at, hopefully, 1 minute left of your 5-minute talk, something that says 1 minute left. So pretty self-explanatory, I hope. And if you're in the audience and you're not part of this and you see like one person closing out their talk and the next person opening up the next talk, there'll be a little bit of that handoff quite a few times here. So, and I may not know, by the way, I'm not an expert in some of the subjects here, so so much so that I might even mispronounce names of things people study, but I'm going to give it my best. So the first talk is by Margaret Pickoff. The title is Optimizing Organic Nitrogen Fertility Practices Through Farmer and Expert Interviews. Welcome, Margaret. Oh, and we're going to hold questions till the very end. We're going to have about 10 minutes, and you can hang around longer than that, but hang on to your questions, jot them down. And if you find questions that work for more than one speaker, you get extra bonus points for that.
Are we all set? All right. Hi, everyone. My name is Margaret Pickoff, and I'm a master's student in the School of Food and Agriculture. Today, I'm going to be telling you about a project that I developed that uses farmer and expert interviews to explore the nitrogen fertility practices of organic grain growers. And I will try to use this. Just as a little bit of background, there's currently really robust consumer demand for organic grain products in New England. And Maine has abundant land resources and a lot of the infrastructure available to potentially make it a really great booming organic grain industry. However, in general, there's a lack of region-specific knowledge about growing practices and management. So according to growers in our region, along with weeds and disease, nitrogen fertility management is one of the greatest challenges to producing high-quality organic grains. And because they're organic growers, they're limited from using chemical fertilizers. So for the most part, their options are to grow nitrogen-fixing legume green manures, purchase organic fertilizer blends, or purchase animal manures from chicken processing facilities or dairy operations. So up until this point, most of my research has been in the form of field-based experiments. However, in the last year or so, I've become interested in how it is that growers make decisions about nitrogen fertility, and also how this information can be used by us as researchers to target the needs, the most pressing needs of the growers in our region. So I developed a qualitative investigation that I'll begin this winter. I actually just got final IRB approval this morning, so it's exciting. It'll be a series of 60-minute semi-structured interviews with organic grain farmers in Maine and elsewhere in the Northeast. as well as with agricultural advisors who will serve as experts in the field. So folks from cooperative extension, universities, or agricultural organizations like MAFCA. And the point of engaging directly with the farmers will be to learn about the most pressing needs with regards to nitrogen fertility management, what appears to be the most successful practices, and with the wider goal of tailoring future research and programming to our unique regional context. So, oh, little stars everywhere. So a project of this sort kind of involves delving into the social science world, which I am not very familiar with. So I reached out to Dr. Jessica Leahy in the forestry department, and she's somebody who has a lot of experience with human subjects research. So she helped me to develop a simple theoretical model that draws on the theory of planned behavior and the reasoned-actioned approach, which are both social science theories that have been used in the past to study farmer decision-making. So it takes into account, let's see, laser pointer? Uh-oh. Oh no, what did I do? I pressed the wrong button. There we go. I won't do a laser pointer. It takes into account contextual factors that help to describe a certain end behavior, which in this case is the grower's nitrogen fertility strategy. And with that, the successes and challenges. In the interviews, I will establish context by asking questions about the growers themselves, their experiences growing, the size of their operation, the major markets that they sell to. I'll ask them to describe in detail the nitrogen fertility practices that they use, to identify the greatest challenges and successes, and also to self-assess whether what they're doing is working or not. So I'm hoping that by engaging directly with our stakeholders, I'll be able to identify major research priorities for the future, develop and distribute outreach materials that can be used by organic growers and their advisors, and make suggestions for future programming to more pointedly target the needs of the growers in our region. I'm excited to get started.
Good job.
We will close out of this.
So Margaret got done ahead of time. That's a great start. And the next talk is by Kisei Tanaka, Incorporating Environmental Variability into Assessment and Management of American Lobster. Take it away.
Good afternoon. My name is Kisei. I'm a PhD student affiliated with EES and in School of Marine Sciences.
Can you speak a little more loudly, please?
Sure. How do I make it into
Here.
full screen?
Here, I can do it.
Oh, it's here.
Yes. You see. Got it?
Yes. Okay, so my name is Kisei, and I am a student at School of Marine Science and Ecology and Environmental Sciences. As you can see from the slide, I study lobsters. I'm here just to give you some of the sneak peeks of my research today. And just to give you a background, the lobster fishery in the United States is currently the most valuable fisheries. 2016, the total landing was worth more than $666 million. And the Gulf of Maine accounts for more than 97% of this fishery species landings. And as you can see, the landings have almost tripled in the last 50 years. And the big question is why, which I'm not going to detail because so many different factors affect this trend. Another big question with this resource manager stakeholder in this region is that there is currently we are experiencing the big change in the environment. So as you can see the top figure, sea surface temperature trend in the last 30 years in the Gulf of Maine, the rate of warming that this region experiences about 97 percentile compared to the rest of oceans in the world. Not just the surface level, both the surface and bottom water temperatures also increasing in this Gulf of Maine areas. So the question is, can we keep the management of lobster resource sustainable? The problem is that current management and assessment of resource is 100% focused on the change in population dynamics and do not incorporate the change in environment, assuming that environment is static. And that is a big questionable assumptions. Objective of my research is that can I come up with some kind of models to help managers and resource stakeholders to incorporate this type of change in environment to assessment and management of lobster fishery resources. So just to give you a quick sneak peeks of my research, that this is the simple model that shows the change in lobster habitat suitability as a function of change in bottom temperature and salinity. As you can see how this lobster is more comfortable inshore in general, but also in the last 30 years, the red color shows the increase in the habitat suitability as a function of a change in temperature. This figure shows that because of the temperature is warming, the environment has become more comfortable for lobsters, which partially explains the increase in landings in these regions. So that's just a type of research can help resource managers to guess what's going on in this field. Another thing, the question is, that are they moving somewhere? If they are, through which directions? So I came up with another model that predicted the shift in lobster distributions in this inshore Gulf of Maine. So that this model predicted the lobster densities in the given areas. We can also predict the change in lobster shift, population shift, over the given time period. So you can see that the red is a prediction, and the blue is the observed shift in lobster populations. As you can see, the model does fairly well, predicting where the lobster is headed to. Okay. Another thing is the climate change, big topic in Gulf of Maine, but we don't know how much that lobster is affected by change in temperature. So this model can actually give a quick prediction of under how much the lobster density changes under warm climate and a cold climate. And the quick takeaway message is that lobster is expected to increase under the warm climate scenarios. You can see this in color figures. The top row shows the warm climate and a cold climate. Okay. Another big topic, lobster shell disease, currently happening, but we don't know where it's happening. Sampling resource efforts limited, but my model can actually tell you where you should be focusing on getting those more informations. So in this Long Island Sound, the sampling estimated the lobster shell disease to be somewhere here, but my model shows it's more to the northeast. So just take a message, this model can help resource managers, stakeholders to explore the complex relationship between environment and resource. And currently these models are being peer reviewed and then distributed to the stakeholders, so they are getting more modifications for the purpose that they are working on. Thank you.
So Margaret mentioned that there was, she's just doing some IRB, Institutional Review Board work, and I just want to say that there's 3 talks coming up on this future of dams, all different angles, but everybody on the team, about 20-something faculty and 20-something students all got IRB, so we can share data across the whole project, and Kaitlyn's going first. Kaitlyn Raffier, and she's going to talk about analysis of dams through fact sheet creation to aid in future dam decision making.
So I think, what do I do
Oh,
here?
can you, no, I think you want to put it here. I'm sorry, I should.
No, you're fine.
Bury it down there.
Just X out of that.
You got it?
Yeah. All right, thank you so much, David. So hi, I'm Kaitlyn Raffier. I'm an undergraduate student from the School of Economics, working under Dr. Sharon Klein and PhD student Emma Fox. And today I'd like to talk to you about my research regarding the creation of dam fact sheets to aid in future dam decision making. So to start, the Future of Dams project is a multi-state project, and it's supported by National Science Foundation EPS COR grant. Within this team, there's a variety of researchers from all different backgrounds. working to look at different aspects of dam decision making and trying to produce tools to help stakeholders evaluate dam trade-offs. Dr. Sharon Klein, Emma Fox, and I are interested particularly in using multi-criteria decision analysis to compare decision criteria and alternatives to ultimately determine the best option for a dam, but to do this we must first look at what those criteria and decision alternatives are. So the purpose of these fact sheets was kind of a byproduct of researchers on the team noticing how difficult it was to actually find certain information on the dams. And not a lot of the data was compiled in one place to be easily accessible for us. So factors such as hydrography, land use history, turbine types, ownership, fish passage systems, etc. All must be considered before deciding to relicense a dam. Relicensing of dams is especially a hot topic right now, and we thought that the creation of these fact sheets could not only help the researchers on the team understand the dams better, but they could also be used as a tool to educate stakeholders and help them weigh the different pros and cons in the dam, for the dams in their area. Some difficulties and limitations that I found when making these fact sheets were that sometimes I did not have access to certain reports because they are considered critical infrastructure, and sometimes the reports are extremely lengthy and hard to understand. So the methods I used to create these included reading through federal reports of the dams that I think Sarah Vogel is going to talk about in a little bit, reading through the dam websites if they had one, stakeholder websites, newspaper articles, and emailing and calling different members who were experts in specific areas, and also people from federal agencies. So here I'm going to show you kind of what the fact sheets look like. This was an example from the Milford Dam project that I worked on. So on the first page you'll see that it gives you kind of highlights, so the dates installed, the owners, location, history, and any upcoming decisions that might be important for the dam. On the second page there's a list of stakeholders and what they do and why they're important to the dam, technical specifics including electricity generation, any fish passage strategies, operation schedules, etc. The third page gives you important media coverage with a summary of the article and a link. It also gives an about the authors if you're curious about me or Dr. Sharon Klein or Emma. And the fourth page gives references so you can look at the exact documents that I used and the people that I talked to. So this is kind of a plug for the Future of Dams blog. That's like a new thing. So I have fact sheets for the Penobscot Mills project, the Ellsworth Dam project, the West Enfield Dam, and Lower Moose Dam that look similar to the Milford Dam example that I just showed you. So if you're interested in looking at these more in depth, the link to the blog is http://blog.newenglandsustainabilityconsortium.org/factsheets. If you don't have time to write that down, I'll be around after to give you that link. It should be noted that the blog is in its very early stages. So we ask if you're here, you're more than welcome to go look at the blog, but we ask that you don't share it more widely yet. Those are my references. Thank you so much.
Cool, thanks.
Yeah, thank you.
So the next presentation is by Nayara Marangoni, responses of potato varieties to, and I'm just going to say pathogens because I can't quite pronounce it, that cause blackleg and soft rot. Good.
Let me see if this works. There we go.
Good.
Thank you very much for coming. I am Nayara Marangoni. I am a master's student at the Howe Lab. We study plant pathology, especially diseases in potatoes, and today I'll be talking about a small piece of my project, which is responses of potato varieties to Dickeya, Dianthicola, and Pectobacterium Parmentieri that cause blackleg and soft rot in potatoes. So just to give you a little bit of background, I have this piece of news from the Bangor Daily News, and it says, Maine seed potato growers contend with new bacteria. Here's the thing. Blackleg and soft rot are caused by these two bacteria, Dickeya and Pectobacterium. Pectobacterium is well established in the United States, but in 2015 we had an outbreak of Dickeya. Nobody was expecting that. We don't know how to deal with it yet. So the symptoms that you see are these black lesions on the bottom of the stems on the field, and in storage you can see maceration on the potato like that. And that happens because these bacteria are pectolytic, which means that they feed on the pectin of the tubers. And another thing that happens is that you have fields with incredibly low emergence. We have reports of fields that had 100% loss, and that means millions of dollars in economic losses, and that is terrible for our stakeholders, which are farmers, and also for the community, because who doesn't love eating potatoes? Since it's such a new bacteria for us here in Maine, we don't have a 100% effective management approach. What we have are suggestions, and our suggestions are sanitizing your farm equipment to avoid spreading, using only potato certified seeds, keep your potatoes cool and dry, and using tolerant varieties. But here's the kicker: there are not resistant varieties for these bacteria. So what I did is I picked 9 varieties that are available commercially, and this is a small subset of my data. I am working with hundreds of clonal lineages, which were kindly provided by potato breeders. And my methodology is I punched a hole in each side of the potato using a pipette tip, 1 centimeter deep. I use 3 replications per variety, and in one side I use an inoculum of Pectobacterium Parmentieri, and on the other side I used Dickeya Dianthicola. And the reason why I picked these two is that Pectobacterium Parmentieri has been reported to cause a lot of storage decay, and Dickeya Dianthicola was found in most of the potato plants that we analyzed. And this is where the stakeholders come into place, because we can only do this if we have samples from farmers. Without that, we can't do anything. So I covered those holes and incubated for 3 days at 28 degrees, and then I cut them at these black lines here, and that is what we end up with. So I measure the lesions, I measure the area of the lesions. So my results for this subset of samples is that for Dickeya Dianthicola, Shepherdie, Katahdin, and Snowden were the varieties that had the smaller lesions of the bunch. Pectobacterium Parmentieri, Dark Red Norland, Green Mountain, and Shepherdie had the smaller lesions of the bunch. What that means is that Shepherdie was the one from this subset of samples that had small lesions for both pathogens. This is not saying that these are the only 2 pathogens that cause the disease. There are many others. But these were the ones that were important to us at the time, so we picked those. And this is not saying that Shepherdie is resistant. As I said, there is no resistant varieties. So what we have is potential tolerance for the future, and that is excellent for potato breeders and farmers. So the take-home message is that these diseases cause incredible economic losses. Millions of dollars. Some growers have gone out of the potato business, so it's serious. Many factors of this outbreak are still under investigation. We have collaborative work with many labs across the United States, and we are working on it. There are no resistant potato varieties, but we are working towards finding a potential tolerant one. And the collaboration between farmers and scientists is fundamental for the progress of this disease. And if you see your potatoes being macerated or with those black lesions, give us a call. We want them. Okay? Thank you very much.
So the next talk is by Andrew Newcomb, a second one in the series on dams that's going on today. The influence of dam management on water quantity in rural New England.
Thank you, David. So I am Andrew Newcomb. and I work in the Watershed Processes and Sustainability Research Group with Dr. Sean Smith in the School of Earth and Climate Sciences here at UMaine, and I also work with the Mitchell Center in their current project called The Future of Dams, which you've already heard a little bit about. And this project is a collaboration with the New England Sustainability Consortium and is funded by EPSCoR and NSF. And so in this research group, the Watershed Processes and Sustainability Group, we take a watershed perspective on sustainability issues, literally. And so this means we use the basic concepts of watershed processes and apply them to answer sustainability-related questions. And so for the next few minutes, the question I'm going to focus on is, what would a river look like without dams? And so we have some context for this in historical records elsewhere in the country, outside of New England. And so I'll want to draw your attention to this figure here, which is a hydrograph with time on the x-axis and discharge in cubic meters per second on the y. And this just shows the flow coming out of a river, in this case the Missouri River, over a series of time. And you can see that in the pre-dam period, before this particular one was built, you have a totally different pattern of flow. You have really high peak flow events during storms, really low base flow events between storms, and then once that dam is built, the signal of the river changes completely. And so taking this concept to a more regional problem, we're trying to identify the signal of dams in a rural New England watershed, which includes somehow putting a number on what the river was like before it was dammed. And so this is an important figure to know for any sustainability-related question. Plenty of stakeholders need information like this to help frame restoration targets, which ties in very closely to any sustainability-related question. So we can figure out what a river would look like without dams by simulating those three basic processes from the last slide, the precipitation, runoff, and channel routing, and applying that to our watershed. So we have precipitation fall over this area. In this case, the green is the Penobscot River watershed. And then runoff occurs over the land, and then routing occurs once it gets into these blue channels here, and the water moves faster there, and it's a different process. This is where the water encounters a dam, is in those reach elements, in the river itself. And so for the watershed scale, we simulate those three. And then on a site scale, what we do is we'll zoom in, and we'll look at a reservoir and a dam in particular, and try to change our physical representation of the watershed from what it currently is to what a pre-dammed physical environment would look like. And so let's look a little closer at a site scale of this. And just as a little aside, you've seen this picture twice already today. Thanks, Kaitlyn, for including that as well. And so at a site scale like this is the Milford Dam right up in Old Town. We see all our favorite stakeholder groups represented in this picture, which is why we keep using it, I think, with those hydropower facilities, Old Town Canoe, Indian Island, some old mills. But anyways, at this site scale, what we would do is take this reservoir back behind a dam and basically subtract from that volume of water the height of the dam. And so take the 18 feet of the Milford Dam and lower everything by about that much. And doing that for every reservoir in the watershed allows us to get a picture of what this whole system would look like without dams like this, preventing the flow of water. And so imagining this picture and quantifying this river without dams is an important step to take in setting restoration targets and in evaluating how sustainable our current dam management practices can be. So thank you.
Next talk is by Matthew Moyet, Degradation of the herbicide Atrazine from drinking water using photocatalysis.
Alright, so I'm going to talk about degradation of the herbicide atrazine from drinking water using photocatalysis. A little about me. I am a graduate student in the Ecology and Environmental Sciences Department, and I do research in Aubert Hall under Howard Patterson. So, atrazine has gained a lot of popularity in the United States in recent years due to its increased popularity in agricultural and commercial landscaping use. And as a result of this increased popularity, we see communities are at greater risk of exposure in these communities. And as a result of that, we do notice that several sources of pollution involve agricultural runoff as well as industrial waste generated by these operations. And as this waste is generated over time, we see communities and certain sources of water, such as dams and other bodies of water, are come into closer contact with these pollutants, and as they mix, they settle over time and begin to accumulate in the environment. And as this accumulation progresses, we do see a sort of phenomenon known as bioaccumulation that occurs due to this enhanced chemical stability in the resistance to breakdown, natural breakdown. And as a result of this, smaller organisms will consume that are coming into contact with this pesticide over time will end up accumulating and gain a higher concentration of exposure, which corresponds to larger predators up in the food chain. Now, current methods to remove this pesticide have varied across different sectors, the most popular being ultraviolet radiation treatment. Now, ultraviolet irradiation treatment involves the exposure of contaminated bodies of water to ultralight irradiation in an event to break down and stop toxic properties of certain pollutants. Now, the role of photocatalytic degradation comes as kind of a co-catalyst with this UV irradiation. So these photocatalysts, as shown here, are inorganic materials that act as excited electron generators that produce reactive chemical species in the form of free radicals. These free radicals are exposed to pollutants, thereby neutralizing their toxic effect and redeeming them untoxic, as well as breaking them down to further non-toxic byproducts. Now, in a sustainability sense, we can use this as an additive to a typical UV ray analysis in order to get greater breakdown of pollutants, as well as the neutralization of atrazine and other herbicides that pose a serious threat. Now, our current work in the Patterson group simply applies finding a pollutant of interest, in this case atrazine, and identifying its concentrations as well as breaking down using these photocatalysts. We identify these concentrations using the luminescent properties in which most chemical species do observe. Now, to increase these catalytic enhancement, we look to have the addition of inorganic transition metals such as copper or zinc in order to act as a further electron generator, if you would, and also to resist the breakdown of the catalyst in order to create more reactive chemical species, thereby to neutralize these to atrazine and other pesticides. Now, as a result, we have gotten sufficient evidence that certain pesticides do react better to other photocatalysts, but in the meantime, we do notice that many photocatalysts reach a kind of equilibrium point. And in order to overcome this equilibrium point is where we've investigated the addition of these chemical species in order to prevent the breakdown of these photocatalysts in a process called recombination. And so far, we've gotten reusability in these photocatalysts with the end goal of placing them on a substrate or kind of medium, if you would, to maintain contact with polluted bodies of water in order to prevent not only the breakdown of these catalysts as well as the mixture of them in the water, because once they are released, they are in a micro, or in this case nanoparticle scale, they are a lot harder to find. So that kind of leads into where, as far as keeping it on films or in more substrate as opposed to a heterogeneous mixture of nanoparticles and water.
Thanks, So the third in the trilogy of dam talks is by Sarah Vogel. Update on what's been happening through the Federal Energy Regulatory Commission's e-library content analysis. You gotta love this stuff, like Sarah does.
Hello everybody, I'm Sarah Vogel. I'm with the Department of Wildlife, Fisheries and Conservation Biology. Like David said, I am with the Future of Dams project. And Maine is a great place to study dams. I should put it on a slideshow first, is what I should do. There we go. Maine is a great place to study hydropower because 25% of our electricity generation is from hydropower. Now that can present a significant challenge to fish, especially fish that need to pass from saltwater into freshwater to complete their life histories like salmon, shad, eels, and others. So the federal entity that regulates hydropower dams in the U.S. is the Federal Energy Regulatory Commission, which issues 30 to 50-year licenses for hydropower projects. It's now actually 40-year default license as of a couple of months ago. And those licenses regulate any fish passage going forward for that period of time. So the process of relicensing is really the best time to influence fish passage for the next 40 years. Relicensing involves many stakeholders over very differing time frames with different levels of authority and within a complex legal system. So it can be complicated. I am focusing on the Kennebec and Penobscot River watersheds, which you see right here. And I'm studying the regulatory decision-making process in those watersheds. How do different factors influence fish passage outcomes? And I'm especially interested at the state, federal, and tribal level. So I'm looking through the FERC e-library, which Kaitlyn mentioned. It's a centralized records database. Contains millions of documents. There's a lot of them. And I'm doing a content analysis of that group of documents using a technique called coding. There are different types of codes that I can use. A priori codes are codes that are based on prior knowledge, so I go in already knowing that I want to look at the types of fish passage or the agency influence. And I'm also looking for emergent codes that come from the documents themselves. So I've been finding that settlement agreement, the influence is very important in some of these licensing projects. There are qualitative and quantitative ways to look at the data and also a mixture of both. One type of quantitative method is to do text searching and coding queries that can tell you about those licenses. For instance, here on the left, you can see that the Burnham Dam was much more focused on fish passage than, say, the West Enfield Dam. So that's a point of interest that I want to investigate further. Word frequency queries also help to see in the documents what is being brought up more often than other things. What are the important aspects? And that can also be compared across different projects and look at how things differ from project to project. And so why are we looking at all these? Why, Kaitlyn? Part of the reason is that over the next decade, nearly 25% of hydropower dams are going to be in need of relicensing within the United States. So this knowledge of decision-making patterns is going to inform future relicensing efforts. So what we're looking for is what has happened in the past and how that can influence the future. And hopefully, for this next round of relicensing, we'll get it right. We'll get some fish through the dams. That's it.
Okay, great job. And last talk by Michaela Murray, Bringing Local Food to All, Challenges and Opportunities in Farm to Institution Initiatives.
Thank you, David. Right.
Good afternoon, everyone. So as David said, my name is Michaela Murray, and today I'm going to be talking to you about how we can start bringing local food to everyone through farm-to-institution initiatives. So what is farm-to-institution? It's pretty much exactly what it sounds like. It's relationships between small or medium-sized farmers and institutions within their area, whether that be schools or universities or hospitals or other similar facilities. And compared to conventional food systems, these relationships focus a lot more on building local relationships and strengthening local economies and communities. So this past summer, I was working for the Honors College Sustainable Food Systems Research Collaborative, and essentially what I did was a massive literature review, and I went through over 40 peer-reviewed journal articles and data sources from Farms to Institution New England. And I used some qualitative coding methodology that Sarah just discussed to start identifying certain patterns that presented themselves in the literature in regards to challenges and opportunities to these sorts of markets. So some of the things I observed in terms of challenges, interest, and education was one that was discussed quite a lot. So sometimes stakeholders in these markets don't really have any interest because they're either unaware that these markets are available to them, or they think that they're too difficult to be a part of because working with conventional distributors is just easier. Oftentimes price and costs are another limitation that people don't want to participate because of. So institutions are often constrained with tight budgets and don't feel that they can afford to purchase locally because farmers will often charge higher prices than conventional distributors. Availability and scale was another issue that was discussed. So farmers are constrained by the growing season, and as we know in Maine and New England, that growing season is relatively short, so sometimes institutions will feel like they won't be able to have a year-round supply, and thus they don't want to participate. Infrastructure is kind of going off of that. Sometimes there's material infrastructure concerns like not having the right transportation or storage facilities available, and organizational infrastructure as well, like how to deal with billing and communication between the supply chain actors. But despite these challenges, there were some opportunities that presented themselves as well. So the utmost being relationships. Oftentimes the relationships between supply chain actors and farm to institution markets is a little bit more close-knit than conventional food systems, so there's higher senses of trust and communication in these sorts of markets, which can help to increase the value of the food product and create a willingness to negotiate between the supply chain actors. Also discussed was the social benefits that come from these markets, which can mean like improved nutrition and improved social justice in terms of having more universal access to healthier foods that farmers can provide. Another opportunity, or in addition to that, environmental benefits was also discussed too. Sourcing local helps to reduce food mileage and resources used. Another opportunity was improved outreach and education. So making sure that all of the supply chain actors are well educated can help to make FTI markets a bit more feasible for them. And then another benefit that was discussed was just the better quality of food that is presented by small farms. So how is this helpful for future farm-to-institution initiatives? So this work has helped to identify some of the gaps in the literature, and this identification has directly inspired some of the stakeholder interviews that my research colleagues are doing right now with stakeholders in Maine. And we hope that the results from the interviews and this work that I did over the summer will inspire future plans of actions to help strengthen farm-to-institution research networks and facilitate stakeholder partnerships in Maine.
So I would love to have all the speakers come up to the front and stand. And I want to say that, A, I'm super impressed because everybody came in under time. So thank you for that. Just a little logistical matter that I've never seen work out this well before. So very impressive. But also, so one of the things I found fascinating in listening to these talks was kind of in all the talks there were issues about sustainability, but I bet they mean different things in different contexts. About stakeholders, where a stakeholder might be somebody who's got a potato that looks funny and they want somebody to look at it. But it might be a grower who's trying to figure out things about fertility practices, and the methods are incredibly variable, right? You know, you have people like doing lab bench analyses to people doing document analyses, people doing sort of human subjects research, and what solutions look like in all these contexts vary. And so I have lots of questions about that I'd love to explore, but I'm not supposed to be selfish here, so you guys get to do that. And I'll sit here and cool my jets.
I've got a question for Nayara. Can you tell me a little bit more about management of these diseases in potatoes and what growers are doing other than perhaps increased sanitation?
Well, that's the thing, because Dickeya is the bacteria that we are mostly concerned about because it's so new for us. And as I said, we don't have management practices that are 100% effective, so we have our recommendations. We know that the disease starts at the potato tuber. It doesn't survive in the soil. We are still investigating if it's coming from irrigation water or if it's coming from coal piles that are still in the field. To sanitize your equipment is one of the main things right now, because what we are trying to do is damage control until we figure out more things to bring that sort of management, integrated pest management, if you will.
Thank you.
Go ahead.
So suppose you got a chance to shadow somebody else who was in this. Who would you shadow, and what do you want to learn from them so that you could make what you're doing better? You don't have to remember their names, just point to somebody. Uh-oh.
Well, in my case, I guess that for everybody else, I could learn to work more closely related to the people that are interested in the research, because most of my work is lab-based, and I mostly receive samples from third parties. I don't actually go and talk to the growers. You know, I just receive on the other end. So I guess that's something that I could learn from everybody else, to be more interactive and to have my research kind of go further.
I'd be interested in seeing what the coding process looks like for you social science folks.
I would also be interested in that. I'm new to it as well, and it's a crazy learning curve because you really don't learn about a lot of social research in the natural sciences. So it's fun. It's a bigger. I'd like to actually know more about lab work and tuber pathogens.
They smell really bad. You ever had a bag of potatoes rot on your counter? You know what I'm talking about.
I was about to say I'd be interested to work with some potatoes, but you don't make it sound so.
It's fun.
I know that probably none of you had everything go really smoothly, right? Right. So, when you hit a point where you were really, really frustrated, and you thought, "Oh man, why did I go to grad school at first?" But how did you handle it? What were some things that we can learn about handling adversity in research?
Have a beer with other graduate students and vent them.
Yeah.
Share your frustrations with others.
I think that's pretty common with, I don't know, I could be wrong, maybe I'm the only graduate student that feels that way, but definitely those times come up, and just talking it out with people is super helpful.
I find, whether it's over a beer or just bothering your office mates is a really great way to kind of just figure things out. And sometimes just getting a fresh set of eyes, even like if it's your office mate or friend who doesn't work in anything related to what you do, the process of trying to explain your problem to them can help you realize the solution for yourself.
it's also important to focus on the like why you're doing the whole project in the first place. Can you keep your eye on like the end goal? That really for me is a personal motivator to keep on going and try to push through that problem.
I also have a kind of developed the mindset that can this stay optimistic? I have lots of problems like that, but somehow I kind of feel that just things just turns out alright again, and it has so far. So it's not that bad.
And that's what we're here for too, is to learn. So part of it.
And remember, you're the only person doing what you're doing. So, like, you're the expert in that specific topic.
A general question. I may not have an answer, but maybe some people have some experiences or reflections on this. But when you're talking about sustainability issues, you're often talking about things for the common good. You know, everybody's presentations are about things that would help make our society better. But when we talk about engaging stakeholders, oftentimes our stakeholders have very personal motivations or individual motivations, or they may not want to share because that might threaten their benefits, profitability. When we deal with farmers, for instance, how have you run into issues of balancing that conflict, or is that something that you've thought about?
So I can say that for my project, it's a huge political issue. It's very controversial, and I have been lucky to have been kind of protected by my mentors, because I am not about to go to the big people and say, here's what you should do. But I think that it comes down to believing that what you are doing is right for your own personal standards. You know, science, at least to me, science is science, it's facts. I can't change the outcome of my experiments to please one party or the other. They are what they are. So it's kind of take it as you will. These are the facts. This is what I've done, and if you don't like it, I'm so sorry.
I think on the same note though, the process of writing interview questions for my project has made me kind of check my assumptions about what is right and what is good. So I think in the beginning, I had all these ideas about like everybody should be an organic grower and everybody should only use legume green manures and no whatever other fertility options and I think this process has kind of showed me that doesn't work for everybody. There's not a one size fits all solution, and so I found that for sure.
With the Future of Dams project, I think we're really lucky to be part of it because there are a lot of people across many different universities working on issues relating to dams. So while I'm just focused on decision making at the government level, there are other people that are focused on NGOs or community members and things like that. So it really helps to paint a big picture of the whole situation. And it's definitely important to remember that there are no evil people involved in these. I know a lot of people really, Brookfield and their dams. But like you said, everybody has their own set of concerns and they don't always match up.
I guess just a kind of general question. So how do you incorporate the values of stakeholders, like just general communities in decision making, such as whether to create fish passages or remove a dam? Once you have the information on the effects of the dam and or what the area would be like without a dam, how do you relay that to general communities and industries and make a decision based on their values?
I think that comes down to what was the topic of last week's talk here in the Mitchell Center, which was decision support tools. And so that's kind of what a lot of, I know, our work in Future of Dams, and I think everyone up here's work, is theoretically supposed to lead towards, is some sort of decision support tool that will, you could, if the stakeholders wanted it, give it to them, and they would look at, you know, a trend line or something and see, okay, if we change something by this much, this natural system will respond in a certain way. As for specifics for a dam or something like that, it just totally depends on who the stakeholders are and how much information they have to begin with. Because we do have such a spread of stakeholders in a large issue like that, and I bet you could probably say that for potatoes or for lobsters or anything else.
I would say too that it's super important, and I'm realizing it more than ever, to be able to talk across disciplines, to be able not just between, you know, other people in the university setting, but to be able to scale down your language so that you can have a conversation with somebody that may not have the same background. And I think it's very important not just to be able to do it, but to look for those opportunities to do it.
If I could just pick up on that, and that's sort of, when should you start those conversations with stakeholders? Do they have to hold up a sign that says, I need a decision support tool? Do you kind of go have coffee with them and find that out? And I was actually going to ask both Matthew and Michaela, haven't heard as much from the two of you, like, what do stakeholders look like in your world, and when and how did you decide, oh, we need to know how they look at the world and what kind of help they need? Maybe Michaela, can you?
Sure. I mean, I wish Linda was still in the room. She's on my research project as well. I know that one of the stakeholders that our research team works directly with is Riley Neubauer, who is a former member of the Armed Institution New England. So she kind of directly, from my knowledge, she directly came to our research team and kind of presented some of the issues that she had been experiencing as working with FINE, and they have more of a direct relationship with farmers. So I personally haven't interacted with, you know, farmers or institutional purchasers or any distributors, but I know that FINE and MEFTI are both stakeholder groups that we're working with that have helped to shape how our research is being done.
So even just having one person who's well connected to that world is a big resource. How about for you, Matt?
So in my kind of line of work, our stakeholders are kind of involved a little differently. Since we're kind of measuring contaminants that have persisted over time, we don't really have as much of an industrial sense as far as a chemical industrial, more conservation based or kind of environmental based. They approach with a problem that these certain compounds, that they're cheap and they're readily used. Well, they are readily used and they stay around for quite some time, but on the offset, they will stay around for years to come. And because of that, our stakeholders are kind of more of we've identified that these compounds are causing societal and health problems in our communities, and what better ways can we kind of go about to remove these? And as well as kind of a catch-22 with this removal, as you break down certain chemicals in water, chemically they may combine to become just as toxic, if not worse, substances. So because of that, we run into more of a kind of medical aspect and kind of really in human ecological aspects as far as how contaminants or these pollutants in our community are detrimental, really.
So I think we're at time. This conversation could go on, and feel free to hang around. I may ask a few more questions, but let's thank them for a great job today.